As the population surges, the number of vehicles are increasing at a humongous rate. Hence, managing traffic for traffic police and dependency on the current traffic control system is becoming really inefficient day by day. Hence, to cope with this situation, we have developed a prototype for density-based traffic control, which will automatically manages the traffic in multi-lane squares to allow the vehicles transport easily by giving appropriate room for lane which consist of heavy traffic. It works on priority basis, setting up the priority for those lanes having more density of traffic.
To develop this solution, we have used Arduino Mega 2560 chip, which is based on Atmega 256 microcontroller, which will control the flow of traffic signals according to the data sent by HC SR04 ultrasonic sensors. Each sensor is provided to each traffic signal lane to check for density by receiving the ultrasonic sound wave sent by the sensor itself. This sensor is effective for range of 4 cm to 400 cm of distance from sensor to object. Now, the requirements of this project are as follows. Firstly, we used Arduino Mega 2560 board. Secondly, cable Arduino to USB. Sensor 8CSR04, resistors of 220 ohms, LEDs which are green, red, yellow of 5 mm length, breadboard, jumping wires, and laptop with Arduino IDE installed for programming.
This is our working project. We have used 4 sets of sensors and LEDs representing a typical traffic square, which is currently under normal working conditions. That is, it is working with each signal having a delay of 5 seconds for red light and 2 seconds for yellow light. Green signal light or green LED would be on till one signal's timing completes. Now, when a vehicle or an object is brought near the signal, the lane would be allowed to get on until its density decreases or delay ends, whichever comes first. As soon as I remove the vehicle from signal 1, its traffic density reaches to almost zero as compared to other signals. Its red light turns on and green LED lights up at signal 2 where golden car vehicle is placed. After removing all the 3 cars from signal 1 to 3, and except 4, only one signal remains on, that is signal number 4. When all the cars are removed from the signal, it returns to its normal working state. That's how the traffic is controlled. The traffic signal ends up with a working time of 7 seconds. Now, let's understand the circuit connections and have a look at code walkthrough.
So, as you can see that on the left hand side, this is the circuit diagram, and on the right hand side, this is the code. We have 4 set of ultrasonic sensors and 3 LEDs, each of red, yellow and green, which represents a single traffic signal. Here we have included timer1.h header file, which is the dependency for the delay and interrupt timings of this system. Now, as you can see that we have 4 arrays, signal 1, signal 2 to signal 4, which consists of 3 integers, or it represents 3 pins. The signal 1 or the sensor of the signal 1 is connected to the pin 23, 25 and 27. Here you can see in the diagram that it is connected to 23, 25 and 27. Now the same in the signal 2, which is connected to 46. Signal 2 is connected to 46, 48 and 50. And this goes up to signal number 4. Now we have given red light delay of 5000 milliseconds or 5 seconds and yellow light delay of 2000 milliseconds. The green signal depends on the trigger pin mode data. Also, we have two pins as functioning as an input and output of the sensor, which is the trigger pin 1 for the sensor 1 and echo pin 1 for the sensor 1, which is connected to 31 and 29 respectively. And we have these 4 sets of these 2 pins. In the setup function, you can see that we have enabled the ultrasonic pins as an output and input. Now, the loop function when continue, it will run up to the delay t, up to the total time t for first signal, second signal and third signal. For each signals we have prepared 4 different functions: signal 1, signal 2, signal 3 and signal 4. Now during that function there is a soft interrupt when the ultrasonic sensor reads an input that is within its range. The timer gets on. For example, here reading from first ultrasonic sensor, we have the trigger pin as low and the trigger pin as high. So we have set the timing. Now as you can see that we have a low function which will low or dim all the LEDs except for red ones for the normal functioning of the signals. This completes the code walkthrough and the circuit explanation for the circuit.
This completes the development and demonstration part of our project. So let us look upon the contribution of each member. Kiranjit Kaur, preparation of presentation and collection of relevant material for the project. Melisha Gupta, interfacing the hardware and collection of relevant material for making of project. Sakshi Magre, interfacing the hardware and collection of relevant material for making of project. MD Kashif Raza, Arduino coding and collection of relevant material for making of project along with video editing. Thank you.